Hello toppers. So today now we are going to start the new chapter which is moving charges and magnetism. Let's begin the topic introduction. So we know about atoms. Atoms are made up of charges. How? What is the charges? So as you can see over there, blue dots. Blue dots showing the electrons which is the negative in charge. And here as you can see the red one and the green one. So these both are what? Proton and neutron. Neutron are chargeless. Okay, so only proton have a positive charge, which is a 1.6 10 to the power minus 19 coulomb. So these are what? Charges. If I'm just talking about how magnetic field lines are created. So this is because of a magnet. So these are the magnet, which is called as a bar magnet. When a glass rod is rubbed with a silk cloth, what would happen? As you can see over there, charges are transferred. So we find some charges are produced because of a transformation of a charges. So what is charge? Electric charge is a physical property of matter that causes it to experience a force when placed in an electromagnetic field. The mean of electromagnetic field is, this is a time varying field. Means whenever electric field changes with respect to time, it will produces a magnetic field and vice versa. So that kind of field is known as an electromagnetic field. How many types of charges are there? So from basic knowledge, we can easily say that we have two types of charges. First one positive, second one negative. Silk cloth become negatively charged, gaining electron. Means if some body will gain the electron, if some metal gain the electron, then that will be negatively charged. And glass rod become positively charged, losing electron. Means if a conductor is losing electrons, that means that conductor becomes a positively charged. What happened when we comb our hair? We saw after a few seconds or after a few while, it can able to attract some piece of a paper. So bit of paper are attracted towards the comb. Why does the comb attracted the bits of paper? So the reason is simple. The reason is when we comb, charges from dye hair get transferred to the comb and induce a dipole in its bits of paper and get attracted. Comb get charged and charge get introduced or induced on paper. Paper is neutrally charged. So when we bring charged particle towards a neutral thing, it develops opposite charges. So the comb get a positive charge and the bits of paper get negative charges. You can see many electrical phenomena also. So, well, what causes lightning? When positive and negative charges grow a large enough, a giant spark lightning occur between the two charges within the cloud. These are like electric static or static electricity spark that we can see. But in the much bigger size, lightning is an example of electric current which we saw earlier. So, what is a moving charge? As we saw in a electrostatic charges are in the rest. So, what is the meaning of a moving charge? Moving charge is an informal way to referring to a charged object changing its position relative to a particular observer. For example, if I'm just taking electric current is a common example for a moving charge. Charges, when the charges start to flow, or the directional flow of a charge produces a current. So, this is a moving charge. How will you differentiate a moving charge from a stationary one? So, moving charges generated magnetic field, while stationary charges generated electric field. Why do moving charges produces magnetic field? These kind of questions comes in your nature? It comes in your mind? Yes, that will be very good. So the magnetic field and electric field are related. As I told you earlier, when the electric field changes with respect to time, that will be produces magnetic field lines or magnetic fields. Simply magnetic field when changes with respect to time, it will be produces electric field, or we can say vice versa. So magnetic field is essentially the relativistic transformation of electric field of a moving charge. Charges produces a field that act on charges, but action of this field looks different from different frame of references. Electric field is something that accelerates other charges. Magnetic field is something that rotates other charges. Point must be noted. Electric field is something which accelerates the charges. Magnetic field is something which rotates the charges. Here we have some questions. Let's revise the topic which we did. So dash is the charge object that changes its position relative to its particular observer. Options we have a positive, negative, stationary, moving charge. So the correct answer for this question is moving charge. Moving ahead. Next question we have. Dash is an example for moving charge. Electric current, voltage, resistance, or none of these. The correct answer for this question is electric current. Next topic we have magnetic field produces by moving charges. So, this phenomenon actually started from the Hans Christian Oersted. The Danish physicist was the first to notice intimate relation between electricity and magnetism during a lecture demonstration in 1820. So he observed that magnetic field is produced by a current carrying conductor. Now moving ahead, the relationship between the current in the conductor and the magnetic field around the conductor was given by Ampere. These laws of electromagnetic induction were put forth by Michael Faraday. He is a very great scientist that gave the idea about that how magnetic fields come in the nature. Like theoretically, if I just state telling that theoretical and experimental investigation indicate that moving charges produces not only an electric field but also magnetic field in the space. So we are going to study the different aspect of magnetic field produced by moving charges. Have you seen this ever? This is a fabulous phenomenon. What we are saying this one. What you observe in the sky, that will be the color of the sky is different from the normal, isn't it? So why this kind of a thing happen? Actually, this is aurora borealis. It's a wonderful phenomena seen in the sky in the polar regions of Alaska and northern Canada. So this phenomena is related to the Earth magnetic field and emission of a light by the moving charges. What could be the reason behind this phenomena? Have you want to know? So when you read the NCRT students, this is a particular like box like a form you will be get the phenomena. So the explanation of aurora borealis. During the solar flare, a large number of electrons and protons are ejected from the sun. Some of them are trapped in the electromagnetic field, that is the Earth's magnetic field, and move in a helical path along the field lines. So, the field's lines come closer to another near the magnetic poles. Because of that, like this. So, because of that, the density of the charge increases near the poles. These particles collide with atoms and molecules of the atmosphere. So what will be happen? Excited oxygen atom emits green light. Again, excited oxygen atom emits green light and excited nitrogen atom emits pink light. Because of this, aurora borealis happens. Now, majority of these colors are this. If the colors are mixed up, so new colors will be formed. Understood? So the mean of like why aurora borealis is happen because of this scenario. I hope this must be clear to you. So deflection of a magnetic needle, when this will be placed in the vicinity of electric or current carrying conductor, the deflection this will be seen happen like this. So can you guess the reason behind the deflection of magnetic needle? Deflection of a magnetic needle or compass due to the creation of a magnetic field. Understood? So if we just take a simply compass and that compass if we placed in the presence of an electric field, like any particular conductor where the current is actually passing, the compass needle will start to deflect because of magnetic field. What it's the sense here, that is the electricity somehow connected with this magnet. This is the actually reason or origination of connection between electricity and magnetism or magnetic thing. So this is all for today's class, students. I hope you understand the topic. So take care, everyone.